Hello, everyone, and welcome to today's presentation. I'm George Mavrakis, Deputy Managing Director of Mavrakis Consulting Engineers, and today, together with my colleague, Mr. Harry Kaplanidis, we're going to present you some of the projects our company has designed using the help of Allplan and Allplan Bridge. First, I would like to introduce your company, Mavrakis Consulting Engineers. Our company was founded in 1999 and is a successor state of the private practice of Mr. Ioannis Mavrakis, who started his career as a civil engineer back in 1978. Infrastructure projects, starting from the initial phase of the conceptual design and going all the way through the detailed design phase, have always been our main area of expertise. Apart from that, we have also been involved in the design of major building, transport, and other civil engineering projects. The ability to deliver short deadlines at the same time in the highest possible quality enhances the competitiveness of our company in the field of structural and civil engineering. Technical excellence, highly educated staff, and teamwork have always been the key assets helping us evolve into one of the most reputable consulting firms in Greece, serving clients in the private and public sectors, both in Greece and abroad. Now, I'm going to hand you over to my colleague, Mr. Kaplanidis, who will continue with the main part of today's presentation.
Hello, I'm Harry Kaplanidis. I work for Mavrakis Consulting Engineers. I'm in the BIM design team of the office, and today we are going to present you some of the projects we have designed with the help of Allplan Bridge. First of all, why we use bridge information modeling? We use for the parametric design, the flexibility, the high efficiency, the quickness and accuracy, the adaptability, easy collaboration, and seamless integration it offers. Allplan Bridge offers all of these features I mentioned, so this is why we have selected it. This is our presentation structure. We're going to present you the upgrading of the Eastern Ring Road of Thessaloniki in Greece. Right afterwards, we're going to present you a second Greece-Turkey cross-border road bridge. The third project is a railway overpass in Germany. The fourth is a new bypass of Igoumenitsa, one of the largest ports in Greece. And the last project is a three-span curved bridge near Kozani in Greece. The first project, flyover project, is a 12-kilometer of highway road. It will have 7.6-kilometer elevated highway with 9 interchanges, 4-kilometer flyover bridge, 9 bridges, 3 tunnels, and once completed, it will serve over 20,000 vehicles per hour. Let's fly through the project. We fly over Thessaloniki. Here is the start of the project. Right afterwards, it's T8 structure and then T8A structure. As we continue to fly through the project, we can see T11 bridge. And here we can see the location of T15 structure. It's a cut and cover. Then it's T19 structure. It's a bridge. Right afterwards, it's T21. It's a tunnel. And near the end of the project is a composite bridge, T23 structure. And here is where it ends, our flyover project. We can see a panoramic view of the city. And here are all of the projects we are going to present you from flyover project. Let's start with T8 structure. T8 structure is a cut and cover with a length of 800 meters with 3 lanes at each direction at level 0 and 2 lanes and an emergency lane at every direction at level 1. It consists of 33 separate segments with over 800 piles. The advantages of this structure is the quick and safe transportation with significant improvement of road safety. With the aim of reducing accidents, it will deflect 25 to 35% of traffic at level 1. Here we can see some recordings from the design process from Allplan and Allplan Bridge. We can see a fly-through at level 0 and level 1, a panoramic view, and the design process we followed in Allplan Bridge. We can see some cross sections here at the right bottom window. Let's have a look at some images of the project. We used BIM Plus for multiple axis import, which helped us to design the walls of this structure. We used Allplan Bridge to design multiple cross sections with plenty of variables. We used also special functions and formulas to accurately design the geometry of T8. The colonnade design was made with the help of other programs too. We exported the station of the colonnades relatively to the main axis of the H structure with the help of Dynamo and Civil 3D, and then we imported in all plan grids. Colonnade design was made also with the help of variation tables. We used Allplan to import the terrain of the project, which helped us to export directly the terrain line in the drawings. We have split our structure into 33 different segments for the reinforcement of the structure. As we can see here, visual scripting played a crucial role in the design process. It helped to place over 800 files easily and quickly and saved plenty of hours doing repetitive work. Then we can see how we can reinforce the piles I mentioned above. The reinforcement of the piles was made with the help of Python parts, and then we created easily and fast reinforcement drawings. In the end, we can see some drawings from this project. Let's have a look at the second structure of flyover project. It's the 8A structure. It has a length of 200 meters with 3 lanes at each direction at level 0 and 2 lanes and an emergency lane at every direction at level 1. It consists of 2 sub-bridges, 15 PS and 46 girders. We can see now some recordings of our design process for this structure in Allplan and in Allplan bridge. We have designed the road above the upper slab with the help of Hunt's function. And we have also imported multiple axes from BIM+. The girders were designed easily with the help of template function that Allplan Bridge offers. And a single change at the template applies to all members of the same type at once. We have also imported the terrain as we did in the previous project, which helped us to check if there were any collision between PS and terrain. Let's have a look at the third structure of this project. It's a curved bridge with a length of 100 meters with 1 lane at each direction. The bridge has great curvature. It's a concrete box bridge with 4 PS and it's seismic isolated. Now we can see some recordings of these bridges from Allplan and Allplan bridge. The road axis and bridge axis were different, and it helped us a lot, the variation tables and special functions that Allplan bridge offers. We have used smart symbols to import seismic isolators in Allplan Engineers from Allplan Bridge directly, and then we can easily check the height of the consoles. Now we can see some drawings of T11 structure, and we can continue to the fourth structure of flyover project, T15. T15 has a length of 700 meters with 3 lanes at each direction at level 0 and 2 lanes and an emergency lane at every direction at level 1. It consists of 26 separate segments. It helps for quick and safe transportation, and it will deflect 25 to 35% of traffic at level 1. Here we can see some recordings from Allplan, a fly-through panoramic view, and a fly-through at level 1 and 0. And we can see also some recordings from all planned bridge and from the reinforcement of a segment. We can see also some drawings that were made in all plan fast and easily. We can see some cross-section types of the project at the bottom left window and a 3D detailed view of reinforcement in the right window. Let's continue with some images of the project. We have also imported this project multiple axes from Beam Plus, and we have designed it with the help of multiple cross-section types with plenty of variables. The colonnades were designed easily with the help of other programs too, as Dynamo and Civil 3D. And the import of the terrain helped us to depict directly the ground plane in our drawings. Here an image from the reinforcement of one of our segments, which helped us a lot to create fast and easily solved drawings. And in the end are some other drawings of this structure. Now let's have a look at another structure of this project. It's T19 structure. It's a pedestrian bridge with 50-meter length, and it serves as a passage for emergency vehicles of the city. It helps the authorities of the city to access a near forest for safety reasons. It has an aesthetic design too. We can see some recordings of this structure from All Plan and All Plan Bridge. Beneath this structure is T15 structure, as we can see here. We have checked if there were any collisions between these two structures. Now let's continue with T21 structure. It's a tunnel with a length of 150 meters and a width of 50 meters. It's a concrete box tunnel with 5 lanes and an emergency lane at each direction. It consists of 2 curved pile walls with 180 piles. We can see some recordings of this project from All Plan and All Plan Bridge. Now let's have a look at some images of this project. Pile walls were designed with the help of Python parts. We used Python parts for importing piles from All Plan Bridge to All Plan Engineers, and the axes were imported from Beam Plus. These are some drawings from the structure. Section along curve function helped us to make the section you see here. Now let's continue with the last structure of this project, T23. T23 structure is a composite bridge of 50 meters length, and it is a Homberg beam type bridge. It consists of 2 lanes at each direction. The advantages of this bridge is a fast and easy construction and the minimum possible disturbance to the traffic level beneath the bridge. Here we can see some recordings of All Plan and All Plan Bridge. As we can see, the composite section was designed as a hybrid between All Plan Bridge and All Plan Engineer. What I'm saying is longitudinal plates were designed inside All Plan Bridge, but Homberg beams were designed inside All Plan Engineer as smart symbols. For the superstructure of the bridge, we used the hunt function for the variable height of road layers. But Homberg beams, as we said, were designed inside All Plan Engineer as smart symbols. Here we can see a more detailed picture of Homberg beams. Changes were made easily and fast and applied to all Homberg beams at once. And here are some drawings of the project from Allplan Engineer. Now let's continue with another interesting project, Evros project. It's a bridge between Greece and Turkey, which will boost the economy for both countries. It's an extra-dosed bridge with two access bridges. It's a part of Egnatia Highway, Thessaloniki-Kipi section, and it's located, I will say, at Greece-Turkey borders. It has a length of 840 meters, 350 meters are in Greek territory, and 490 meters are in Turkish territory. The length of the main bridge is 400 meters. It consists of 13 piers, 2 pylons of the main bridge, and 2 abutments. It has 80 stay cables and 400 tendons. It consists of 296 piles. Here are some recordings from the bridge, a fly-through under the bridge and a fly-through over the bridge. Here we can see some recordings from the reinforcement of the bridge, of the concrete blocks of the bridge. We can see also some recordings from Allplan bridge, as we have designed multiple cross-section types for the main box, for stay cables, and for the abutments and piers of the bridge. We have also designed the tendons of the bridge, as we can see here in the 3D model. Let's have a look at some images of this project. The definition of main geometry was made in Allplan bridge, but special geometry like elliptical cross-section pylons of variable dimension were made in the end in Allplan Engineer. Allplan bridge offers robust tools for fast and comfortable design. As we can see here, some images. As we said, we have designed tendons of the bridge inside Allplan bridge, and tendon couplers are imported then as smart symbols inside Allplan Engineer. Allplan bridge offers the feature for effortless tendon propagation. Then we can see some images of the reinforcement in concrete box of the bridge and some reinforcement of the girders of access bridges. In the end, there are some drawings of the bridge that were made within Allplan. Let's get to a railway project in Sieverstadt, Germany. It's a project that will help for safer transportation and fastest transportation too. As you can see, here is the location of the project. The vehicle road has a length of 200 meters and the railway overpass has 30 meters length. It boosts faster railways and safe vehicle passage. Let's have a look at some fly-throughs from this project and some recordings from Allplan bridge. Now let's have a look at some images of this railway project. The main geometry definition was made in Allplan bridge, and the modeling of composite bridge was made afterwards in Allplan Engineer, as well as the metal seats you can see in the images. Beam helped us for smooth and seamless communication between all the disciplines that were working in the same project for better understanding of the structure and collaboration between the members. Now are some images of the rebars for the upper slab of the bridge and the abutments of each two. In the end, are some drawings of this project. Let's have a look at our fourth project, Igoumenitsa project. Let's fly through Igoumenitsa project. It's located near Igoumenitsa, one of the largest and most congested ports in Greece. The office has undertaken two main structures in this project. The first one is a double cavern cut, and the second one consists of one cavern cut and twin tunnels. Here is a panoramic view. Let's delve into the first structure. A double cavern cut has a length of 325 meters and two lanes in each direction. The advantages of this structure is the seamless vehicle traffic at above level and the reduction of visual impacts in the landscape. Here are some recordings from Allplan Bridge and Allplan Engineer. Let's have a look at the second structure of this project, the twin tunnels with a cavern cut in front of them. The cavern cut has a length of 160 meters, while the long tunnel has a length of 230 meters, while the short tunnel 170 meters. There are two lanes at every direction. The advantages of this structure are the significant increase in vehicle traffic volume and the drastic reduction in commuting time. It will help people bypass the city of Igoumenitsa, one of the largest and most congested ports in Greece, as we said earlier. Here also are some screenshots and recordings of the project, some cross sections of the tunnels, emergency sections, some sections of the cavern cut. And let's continue with the last project, which is a bridge, Handakas project. It's located near Kozani, city in Greece. It has a length of 100 meters. It's seismic isolated with a great curvature. Here you can see some screen recordings from the reinforcement of the bridge and of the design process inside Allplan Bridge. We reinforced fully our model, the concrete box, the piers, and the abutments of the bridge. We have also placed the tendons of the bridge, and we made a check for possible collisions between tendons due to the great bridge curvature. We have imported the terrain of the area in order to define the pier level foundation. And here are some drawings of the bridge. I would like to thank you for your attention, and I hope you found interesting the projects we presented you.